I'm here again with another exciting video. Today we'll be talking about Kepler's third law of gravitation. So Kepler's third law states that the square of the time or period t of a planet around the sun is directly proportional to the cube of the semi-major axis or average radius r. So in general, t squared was directly proportional to r raised to power 3, where t is the time or period it takes a planet to go round the sun, and r is the average radius. Now let's give a diagram for more explanation. Assuming this is the orbit of a particular planet P, we all know that orbits are in ellipse, in an elliptical shape, not really circle. And take for example, this is our sun. So the distance between the planet and the sun is r, which is the average distance, and the time it takes this planet to go around the sun to this very point is t, the period. So most of Kepler's observations were based on observing with his naked eyes and collection of facts from other astronomers that existed around this period. So in order to prove that his law is correct, we need to be conversant with gravitational law. And the gravitational law says the force of gravity between two bodies, gravitational constants, and the mass of the two bodies divided by the square of the distance between them, taking this as the two bodies. So in the case of the planet and the sun, the gravitational force between them is g, mass of the sun, mass of the planet, divided by the distance between them. This is a circular motion where the planet goes around the sun. So the centripetal force, which is the force keeping the planet in the sun, the force that is keeping the planet in the orbit, is the same thing as the force of gravity. The force that holds this planet in its orbit, which is in circular motion, the centripetal force, is the same as the force that is exerted on the planet by the sun, which is the gravitational force. So that being said, centripetal force, we all know, is equal to the mass of the planet divided by the speed at which it goes round, or the velocity as the case may be, divided by the radius, which is the average radius between the sun and the planets. Now let's get to the proof. Angular velocity is equal to the linear velocity divided by r. which we know as the radius. So therefore, the force of the centripetal force rather is equal to mp multiplied by v over r multiplied by v, which is the v square, and this is equal to mp v over r, as you can see here, is w v, and v from here is equal to w r. So with this we can say that Fc is equal to mp w square r. That is by substituting this in this. So from the previous equation we got Fc equal to mp w square r. We can get started. W is equal to the angular distance, which is 2 pi. 2 pi, that's in radian, the distance around the full circle, divided by the time that we know. So we can say that our Fc is equal to mp 2 pi over t square r. So Fc becomes 4 pi square mpr over t square. Then bearing in mind that Fg equal to Fc and Fg equal to gm son mp over r square, we can therefore say gms mp all over r2 is equal to 4 pi square mpr over t square, and this goes. Therefore gms t square is equal to 4 pi square r3. So therefore t square equals to 4 pi square r cube over gms. So we can see that we've actually proved the theorem. What we were to prove or find out was that truly t square directly proportional to r cube, and we proved that t square equal to k r cube, where our k is 4 pi square over gms. So I hope you understood. If we start from the beginning, where to prove Kepler's law and how to confirm or prove Kepler's law, and that we did. We found Kepler's law. Kepler said that t squared is directly proportional to r cube. T is the time and r the average radius, using the gravitational law, which we are all conversant with, and the fact that the gravitational force is equal to the centripetal force. We could derive this, and finally, using mathematical technique and substitution, we derived this and proved that truly t squared is directly proportional to r cube, and the value of the constant is 4 pi square over gms, where ms is the mass of the sun. Thank you very much. Don't forget to subscribe to my channel, drop a like, and leave a comment. Thank you.